Morning, everybody. I hope most of you are on time zones a little bit east of here, so it's say like 10 in the morning instead of 8 in the morning. But and for those of you who came from the west, then you have my sympathies. But anyway, good morning and welcome to MIT. So I want to start a little bit talking, excuse me, about the new MIT Schwarzman College of Computing. And then I'll spend time talking a little bit more about AI specifically. But we're clearly living in an era today of computing, and and the rapid evolution of AI is probably the most salient, most visible piece of that rapid change to nearly every aspect of human endeavor that's been occurring over the last few years. That rapid change is not only, could someone grab me a water? That would be great. That rapid change is not only in all the aspects of humanity that are being affected by this computing and AI technology, but in the core of computing and AI itself, which are also rapidly changing. So I wanted to share a little bit about what we're doing at MIT to address this era that we're in. And the MIT Schwarzman College of Computing, which is a brand new activity at MIT, is a key piece of what we're doing here. It's motivated by these rapid changes, particularly in AI, but also more broadly in computing, both nationally and globally, but also more locally here at MIT. There are academic needs that really aren't being well met by current academic structures. And as one example, a particularly salient one for many of the faculty and students at MIT is about 40% of MIT undergraduates are now majoring in computer science. And that's happened over a small number of years, but about 7% of the faculty at MIT are in computer science. So that necessarily leads to rather large classes and an imbalance. Thanks so much. And leads to large classes and a definite imbalance in the ratio of students to faculty across the institute. Now, of course, in a non-academic world, the answer would be, well, just grow the faculty to match the students. But in the academy, that doesn't make a whole lot of sense. MIT has a broad mission. It's not all about computer science. You don't want 40% of your faculty in any particular discipline. So the conventional academic structures are not working so well. And it may be a little more extreme here at MIT, but it's something that every academic institution is facing. So informing the Schwarzman College of Computing, which is just getting underway now, so this next semester we'll have the initial structure in place, which is literally we start classes again about 10 days from now. We're addressing three key challenges in building the college. So I want to tell you what those challenges are and then tell you a little bit about how we're working to address them. So the first is this rapid growth and change in computer science and AI. And when we say computing in the College of Computing, we mean computing broadly: hardware, software, algorithms, and artificial intelligence. The second area that we're addressing is computing across every discipline. Computing is changing every area of academic inquiry. It's changing things beyond academia, and this calls for structures that help us build better collaborations between academic disciplines, between computing and non-computing fields, and also between academia and the world more generally. So that first piece is rapid growth and change in computing. The second is computing across the disciplines and beyond academia. And the third piece is the social and ethical challenges and responsibilities of computing. Technology always can lead to both positive and negative outcomes. And the early days of computing, which would be much of the last few decades, have certainly been dominated by assumptions that tech was somehow going to always lead to good. And so the disruption or whatever that one was going through was going to lead to a positive outcome. That, if you look at the broader history of technology, is certainly a naive view, that new technologies over centuries have had both positive and negative outcomes, and it's important to pay attention to both of those to try to maximize the positive and minimize the negative. So the three things we're addressing are growth and changes in computing, computing across all disciplines and beyond academia, and the social and ethical responsibilities of computing. I think with regard to all three of those, one of the things that is fair to say about computing is that today the practice is often ahead of the understanding. And we particularly see that with artificial intelligence and machine learning, where even our technical understanding of what machine learning methods are doing is often not all that solid. But when people run out and start using this stuff, the ways in which they're using it and the potential outcomes of that are not things that are well understood. But it's true more broadly across computing generally, that it's not an unfair characterization to say that the practice of computing is often ahead of the understanding. And there are amazing parallels, actually, to the era of early era of industrialization in the United States in the second half of the 1800s. So in the late 19th century, MIT and a bunch of other technical institutions were founded exactly to address a similar kind of lack of understanding that the practice of what was then called the mechanical arts, which we today call engineering, was out ahead of the understanding. So we're really in such a time period, again, we would argue, and this is MIT's response, not to create a new MIT, but to undertake the biggest changes that we've made at MIT in many decades, probably at least 75 years. So what are we doing? Well, one, we're actually growing the faculty of MIT, which is something that institutions of MIT's level of maturity very rarely do. So we're growing the faculty by about 5%, hiring 50 new professorial positions. About half of those are in core computing, and the other half are joint between computing and other disciplines to really start to build the structures that tie computing across all of MIT from an educational and a research perspective. Another thing we're doing is creating some important new organizational structures at MIT. One is called the Common Ground for Computing Education, and that's to bring together multi-departmental teaching and curricula, developing classes and programs that blend computing with other disciplines. So at MIT, we've already started prior to the college to create some blended majors. One of the more successful ones of those at the moment in terms of the students voting with their feet is 614 in MIT lingo, or computer science and economics to the rest of the world. And CS and econ are a pairing of disciplines where there's real demand out there for people who have that set of combination of skills. And there are many such potential combinations, but to treat them all as one-offs doesn't make sense. And so part of what the Common Ground is about is to bring together computing and other disciplines to think both about individual classes, but also about minors and majors across the institute in a collaborative and coherent way. We're also creating a new interdisciplinary focal area at MIT called Social and Ethical Responsibilities of Computing. That's co-headed by two associate deans, one who's from engineering and computing, and one who's from the liberal arts, because today we don't actually have much in the way of leadership, not only in academia, but in the world more broadly, that deeply understands the humanities and social sciences of the liberal arts and deeply understands the technology of computing and engineering. And so the leadership of that is actually two people who bring those together. And as this experiment that we're undertaking here at MIT reaches fruition, we will be training the kinds of people who will be able to be a single leader. Our president at MIT refers to these as bilinguals, people who know computing and other disciplines. But today, there's nobody who can lead social and ethical responsibilities of computing in an MIT academic context who really brings the right level of depth across those areas. We're also making big changes to existing things at MIT. So the Electrical Engineering and Computer Science Department, EECS, the largest department at MIT, has reorganized itself into three overlapping faculties focused on electrical engineering, on computer science, and on a new area called artificial intelligence and decision making. And this AI&D area brings together the computer science heritage work in AI over the last, at MIT, almost 50 years, and work that dates even longer than that around decision theory, decision making, information theory, and electrical engineering. We're also bringing together a number of other academic units that are focused on computing. So the Institute for Data Systems and Society, the Center for what's now called Computational Science and Engineering, was called Computational Engineering until just a few days ago, Operations Research Center, Computer Science and Artificial Intelligence Laboratory, and the Laboratory for Information and Decision Systems. These are all academic activities at MIT involving hundreds of faculty and thousands of students that at their core are fundamentally about computing broadly construed. And bringing those together to work in concert and to work collaboratively across all of MIT is a very important part to realizing these three outcomes of supporting computing and the rapid changes in computing, supporting computing across the disciplines, and supporting the social and ethical responsibilities of computing. So we're at the very early stages of this college. There's a lot to come, but I want to stress how this is important. It's also urgent, so there can be things that are important in academia that take us many, many years to plan and many decades to implement. We're trying to be on the months to plan and the years to implement schedule rather than the years to plan and the decades to implement schedule, which for academia is like greased lightning, but still not fast often compared to the rest of the world, except of course government. I do have to make one reference to my previous life at Cornell Tech, which is a new campus that I was involved in building in New York City. And when Michael Bloomberg was the mayor of New York, that was when that project started. And Mike has always got interesting sort of little snide comments that have a lot of truth to them. And he would often start things by saying, yes, so here in New York, we're bringing together academia and government. And then he'd stop and he'd say, to move quickly. That sounds pretty strange, doesn't it? But in the end, Cornell Tech did actually move quickly, and I think is the kind of example of the fact that we can move very, very quickly here at MIT, and I know we will. So these are important and urgent changes for MIT, for academia more broadly, and for the world that we as academics serve. All right, now to today's topic, AI, and particularly AI in Latin America. So I want to start with sort of some high-level questions, like what is AI? And I pose that question semi-seriously in the following sense. I don't think there's actually a good definition of artificial intelligence. Back when I was a grad student here 3 decades ago, we used to always joke that AI was the stuff that computers couldn't do yet, and as soon as computers could do it, it was software and it wasn't AI anymore. And there's still some truth in that joke. But I think that that AI is probably better defined in terms of the types of things that it's able to accomplish than the specific technologies that are being used to deliver it. And so when I think about AI, I think about things that machines that are able to exhibit human-level reasoning, human-level decision-making, human-level prediction abilities, human-level perceptual abilities, regardless of whether that's machine learning or maybe something like linear regression, which most people would not call AI, but may be being used to solve those same kinds of problems. And I think it's very important for us to always remember that AI is not human, and to fight the natural tendency to anthropomorphize artificial intelligence. In some sense, when McCarthy and Minsky and others in the 1950s held these workshops and coined the phrase AI, it was a bad choice because it sounds too human. AI does not have morals. AI does not have values. AI does not have motivation. AI does not have intent. AI does not have desire. These are all fundamentally human things. Now, the human developers of these technologies have all of those attributes, or hopefully all of them. The people who are using AI to do things have these. So it's not that you don't have to be careful about how AI is used. It's not that you don't have to monitor and regulate and think about AI and the impact that it's having on society with the kinds of new capabilities that it brings to bear. But it's not the AI itself that has those motivations. It's the people who develop it and who use it for particular uses. And I think it's very important, especially with everything out there in general public understanding, and to draw the line between science fiction and reality. So the modern era of AI is really driven by advances in machine learning. And I'm going to date that modern era to about the late 2000s, maybe 2007, 8, sometime around then, when machine learning really started to surpass what I would call more classical AI techniques. And actually, if you look at the development of machine learning and of classical AI, they both started in the 1950s. It's not like machine learning is some brand new thing that displaced other approaches in AI. It's that it was dormant in many ways for a large number of years before we had a lot of advances due to both algorithmic advances and huge advances in collection of data and of computation. But if you look at the whole history of AI from the 1950s, I think it's fair to characterize that up till about the early to mid 2000s, there was significant progress over that 50-year time period, but it was very uneven. So, speech recognition really kind of worked relatively well by 2005 or 6, but nowhere near as well as it does today. You couldn't have the kinds of conversational devices like, Amazon's Alexa or Google's Home or these devices that you can really talk to almost like another person. It was those annoying things you talk to on the telephone that you sometimes had to repeat yourself 5 times, and you better not have sentences that were too complicated and so forth. But they were amazing advances compared to what was there before, and they clearly were showing human-level kinds of competence in things. But the rise of machine learning has fundamentally changed the game, not just in AI and machine learning, but it's really changing the nature of algorithms and of software, because it used to be that to build software to solve these kinds of complex tasks, you needed to do painstaking human engineering of the code. And today, you need to do painstaking training of your machine learning algorithm, plus a little bit of painstaking coding around the edges, but it's a lot less work than this completely manual development of this kind of software. And that is a really fundamental advance that's completely changing the nature and the applicability and the breadth of AI, either through training via training data or through competitive training, which has thus far been most useful in a games type setting. What I find most interesting about these advances in AI, because in the end I'm an academic and I'm kind of, I'm amazed by the progress and how these things can be used, but I'm also looking for the things that might be real changes in sort of how we're undertaking AI and how people are interacting with AI. And one of those changes, I think, is well exemplified by AlphaZero, which is the system that the DeepMind folks, the Google company in the UK, developed, that is now the best both Go and chess player in the world. And those are games, they're not the real world. But I think there's some very interesting things to learn from that. Because AlphaZero doesn't just beat human experts. It plays those games in innovative ways that people have not seen before. In the thousands of years of history of playing, particularly Go, but also a long history of playing chess. So these systems have learned tactics, strategies, approaches that people never discovered. And so people are actually now learning from the discoveries of the machines. And I think that that is a really interesting change in the nature of people and our relationships with computation. Because it used to be that we were always the ones creating what the computing was doing. And now computing is able to discover and abstract things, often in very limited cases still. I'd be happy to have a debate about whether this is really happening outside the area of game playing. I think it is. It's starting to, but it's certainly most clear in games. I think we're starting to see a little bit actually in the area of medical diagnosis, particularly in interpreting radiological scans, where the machines are now starting to discover things where the people are sort of, how did it find that there? I can't see that. And so those are the early things that cause people to look and say, all right, I need to learn from the machine. And I think that that's a really fundamental and interesting and important change. But machine learning is not magic. AI is not magic. There are many limitations still to machine learning. Lack of data, things that can't be trained in a sort of competitive scenario, game playing type of scenario, places where there's plenty of data, but we still can't achieve good training outcomes, places where we actually want to understand why the system made the decisions that it did, not so good in machine learning these days. Black box, here's the answer, take it or leave it. And particularly where there are decisions that affect human lives, human well-being, we care a lot about the why and not just the what. And there's certainly a lot of research these days about explainable AI. That's a place I'm not so optimistic at the moment, partly because I don't think those are well-defined problems. People are not so good at explaining themselves. We're good at rationalizing things. Those are not sound and logical explanations. Just look at a bunch of politicians in the world today. Maybe particularly here at home, but not only in the United States. So I think those are hard things for machine learning and AI. There's another thing that's hard, which is machine learning remains quite brittle. There can be very surprising outcomes. So I'm a computer vision guy. You can take two images that to humans don't look that different, and the machine will very well label one of them correctly a dog and very well label the other one something completely bizarre like a spaceship or something that, it's like, huh? Where did that come from? But that's a place where I think there is a lot of progress in the research community. And I think that we're developing reasonable measures of what it means to be robust. And some of my colleagues here at MIT are leading some of that along with others. And that's a place where I'm quite optimistic about progress in machine learning. Another place I'm optimistic right now is machine learning generally takes lots of data. Sort of data is king, more data is better. I think we're on the verge of places where it's going to become more and more clear that well-chosen data is more important than more data. And especially when we think about robust machine learning. So those are places where I think there will be a lot of progress in the coming years. And whether that's 1, 5, or 10 years, I make no predictions. Research moves at various speeds. So now to the societal impact and the responsibilities of AI. The first thing I want to stress is that AI is particularly salient, partly because of the analogies to science fiction. It's really caught the popular imagination. But societal impact and societal responsibilities are critical for all of computing, not just AI. They're critical for social networking, which in general is not AI-driven. They're critical for even the most mundane aspects of computing when they affect people's daily lives. And it's not that easy to think about societal impact of computing. And that's one of the reasons that we're really building up a significant effort here at MIT, and it's something that's going to take us real time to do so. I want to give a couple examples from face recognition because as a lifelong computer vision researcher, even though I haven't worked much in the face recognition area, it's something I understand quite well and I think illustrates a lot of the challenging issues. So recently, there's been a lot of concern about face recognition and privacy. Very legitimate concerns. You're walking down the street, there's video cameras all over the place, your identity is no longer necessarily private. But while that is true, I'm really dismayed at the reaction of certain localities, for example, San Francisco. There's a bunch of places, including the city of Cambridge here, debating this, banning the use of facial recognition. Now, of course, they can only ban it for their own city agencies. But there are lots of technologies that compromise privacy. And one needs to think about that whole. And it could be that in the end, banning certain technologies in certain contexts absolutely is important. But these are sort of knee-jerk, poorly thought out bans. For example, facial recognition, while it can compromise privacy, is also proven particularly useful in things like finding missing persons abducted children, things that actually a bunch of the other privacy compromising technologies like this thing that you carry around with you everywhere. Cell phones are amazing technology compromisers, both because your phone carrier and the phone carriers are roaming on know where you are at all times, but also most of these apps that you install here are happily telling the servers in the cloud of these app providers exactly where you are and what you're doing 24/7. So on the one hand, we're happily carrying around with us at all times things that compromise our privacy, and yet we're having knee-jerk reactions to something because it's new, it feels like artificial intelligence, maybe it's human, maybe it's going to think on its own, and it's going to chase me down the street. No. So I don't want to come across at all as not being extremely concerned about how all of these technologies are affecting privacy today. But I do want to emphasize that singling out a particular technology because it's new, without thinking about benefits and costs to privacy and other attributes of these technologies, and where they should and shouldn't be used, blanket bans on something new is ignorant, unless it's something that's really been shown to be much more dangerous than the other things. And I hope we're not living in a place where such ignorant decisions stand. So the other concern with face recognition, which is one that's much more complicated, and where I do think regulation is extremely important quickly, but again, we need to look at a broader context, is the question of bias in face recognition. And that's another one that's been raised quite a bit recently. Many of the early concerns about bias weren't actually that well substantiated by careful studies, but NIST, the National Institutes of Standards and Technology, branch of the United States government, in December completed a quite broad-based study of a bunch of facial recognition algorithms and found that their recognition accuracy, so their accuracy in correctly identifying a person as being the person that was actually there when you knew the ground truth, varied wildly, depending on skin color, age, race, hair color, all kinds of things that are not desirable properties to have the accuracy of these things vary on. But again, I want to emphasize that this kind of bias, while it's very salient in face recognition, is present in all kinds of algorithms, be they artificial intelligence or not. And so what I hope is that the fact that bias in face recognition is very visible to people will become a broader call for us to develop regulation and frameworks for looking at bias in algorithms more broadly. And when I say that, I want to stress the even broader context, which is that people are incredibly biased in their decision making. And so I am actually optimistic about a focus on bias in algorithms, which is I think that the long-term outcome of a focus on bias in algorithms will be a less biased world than the world we live in today, where biased people are making decisions and nobody's monitoring what they're doing. Because the algorithms are easier to monitor than people. And therefore, it will be easier to actually get unbiased outcomes. Now, this, of course, depends what we all mean by bias. And so this comes back around to the fact that my definition of bias and your definition of bias may not be the same. And those definitions vary regionally within a country, they vary between countries, they vary in continents and subcontinental regions. And that's why I think when we think about the development of AI and computing technology today, where the United States and China are clearly leading compared to every other nation and region in the world, those are particular, quite different, but particular societal norms in each of those two countries. Those are particular distributions of racial and other identities in those two countries. It's imperative that the world, and that Latin America is a very populous area of the world, are engaged deeply in the development of AI. All of us need to be sure that, our societal norms, our heritage, our culture are preserved in AI and in other development of computing technologies. So with that, here's to a really great day here today at MIT and a great week with the follow-on activities to the Latin American Summit. I really want to thank all of the organizers for this. I know how much work it takes to put one of these things together. And so thank you all for being here, and thank you to the organizers.